let us learn the complete information on nuclear reactor. A nuclear reactor is a device where chain reaction is controlled and thereby the energy released can be utilized for peaceful purposes like generating electricity, etc. The principle involved in the nuclear reactor is a nuclear reactor works on the principle of achieving controlled chain reaction in natural uranium 238 enriched with uranium 235, consequently generating large amounts of heat. A nuclear reactor consists of the following parts: 1. The fuel, 2nd. The moderator, 3rd. The control rods, 4th. The radiation shielding, and finally the coolant. The diagram of a nuclear reactor depicting all the 5 parts is as given here. Let us learn about each part of the nuclear reactor in detail. First, the fuel or the fuel rods. In a nuclear reactor, the nuclear fuel is fabricated in the form of thin and long cylindrical rods. These groups of rods treated as a fuel assembly. These rods are surrounded by coolant which is used to absorb and transfer of heat immediately produced in them. A part of the nuclear reactor which is used to store the nuclear fuel is called the core of the reactor. Natural uranium, enriched uranium, plutonium and uranium 233 are used as nuclear fuels. The second part in the nuclear reactor is moderator. This is used for slowing down fast neutrons. We make use of heavy water or graphite as moderators in the nuclear reactor. The third part in the nuclear reactor is control rods. These are used for controlling chain reaction by absorbing the neutrons. Cadmium or boron rods are used as control rods. Next, the shielding, radiation shielding. During fission reaction, beta and gamma particles are emitted which are harmful to human beings and thus they are absorbed by concrete shield or steel or lead sheets. The next part being the coolant. The heat generated in fuel elements is removed by using a suitable coolant like water or molten sodium. Let us learn the working of a nuclear reactor. Uranium fuel rods are placed in the aluminum cylinders. The graphite moderator is placed between fuel cylinders. When a few uranium 235 nuclei undergo fission, fast neutrons are liberated. These neutrons pass through the surrounding graphite moderator and lose their energy to become thermal neutrons. These thermal neutrons are captured by uranium 235 to carry out the chain reaction. By proper arrangement of control rods, the fission events are suitably controlled. The heat generated is used to convert water into steam, made to rotate steam turbine and thereby driving generators for production of electricity.